explain for this video about the why behind for the area of an ellipse without using calculus. So first I want to give the main explanation. So first I want to talk about the area of a unit circle and then stretch it and then stretch it again to get a general ellipse. And now when we have the formula of this general ellipse, make sure it works for a circle because we already know what the area of a circle is. And then I want to talk about specific explanations for specific questions about this main explanation. So first, why would stretching a circle create an ellipse? And second, why would there be an increase of area by the same amount that you stretched it? So let's get our unit circle. So here's a circle, but for it to be a unit circle, the radius needs to be 1. Now what is the area of a circle? It is pi r squared. For a unit circle, that would be pi 1 squared or just pi. Now let's stretch this unit circle. Now we're stretching it horizontally, so this length would still be 1. However, this length would be something other than 1. Let's call it A. Because we're stretching it by A, the area would be pi times the amount we stretched, or pi A. Now stretch it vertically. So that means that this length is still A. However, we're stretching it vertically, so this length I marked as B would no longer be 1. It will be something other than 1, and so let's call that B. And so that means that the area would be pi AB. We're multiplying by B because we stretched it by B. And now let's check that this formula works for a circle, which is a type of an ellipse. Now here's a formula for an ellipse. Now for a circle, A and B will be equal. They're both the radius. And so we have radius labeled here for A and B. And so that means that the area of a circle will be pi r, or pi r squared, which is indeed the area of a circle. Okay, so why does stretching a circle create an ellipse? So for example, let's use the unit circle. Now what is the equation of a unit circle in rectangular coordinates? It is x squared plus y squared is equal to 1. Now let's stretch it horizontally. So we would get x over a, and that squared plus y squared is equal to 1. And simplifying, we get x squared over a squared plus y squared is equal to 1. Now let's stretch this vertically. The change we have is y over b, and that will be squared. And simplifying, we get x squared over a squared plus y squared over b squared is equal to 1. And that is the equation of an ellipse in rectangular coordinates, and therefore stretching a circle creates an ellipse. Okay, so why does stretching by a certain amount cause the area to increase by that amount? So here we have a unit circle which area is pi, and we stretch it horizontally by A. Now let's split up this unit circle into rectangles. Now you would actually have more and more rectangles to better and better fit the circle until you have an infinite amount, but so that you can see the rectangles, I'm just having a finite amount. And let's split up this ellipse into its rectangles as well. So for each rectangle, we're increasing the area by A. That means that the total area is increased by A. And so the area of this ellipse would be pi A. Now let's talk about more general ellipse. So we're stretching it vertically. So let's split it up into its rectangles this way, and let's again do that for this general ellipse. Now for each of these rectangles, the area is increased by B, therefore the total area is increased by B, and therefore the area of this general ellipse would be pi AB. Thank you for watching this video. If you would like to, feel free to click on this playlist to watch more similar videos.